In this video, I'm going to go over how to solve quadratic equations using three different strategies. The first one will be factoring, then completing the square, and finally resulting with the quadratic formula. So first off, factoring. All right. Whenever you're solving any of these, whether it's by factoring, completing the square, or with the quadratic formula, the first thing you want to do is set these equal to 0. You want to tell your brain that I'm trying to figure out the values for x that are going to make this entire function become 0. Okay? Now, because there is an imaginary 1 in front of this x squared, all I have to do to factor this is think, are there factors of negative 12 that are going to add to negative 4? So there are two numbers out there that when I multiply them, I get negative 12, and when I add them together, they give me negative 4. So write x and x. So I'm thinking of the numbers. I'm thinking 6 and 2. All right, so let's do a minus 6 positive to see if that works. Negative 6 times 2 is negative 12, so that's good. Negative 6 plus 2 is negative 4, so that's good. Now, a lot of students will stop here, but we do want to find these zeros by continuing to go forward by saying, setting each of them equal to 0. All right, so x minus 6, the value that would make that 0 is 6, with the idea being that if I make that entire factor become 0, then the whole thing becomes 0. Same thing over here. What would make this factor become 0? That would be negative 2 plus 2 would be 0. So each of these answers would be a 0 because when I plug it into this original function, I would get 0. That's factoring. Let's do another factoring, but a little bit more complicated because the number in front of x squared is not 1. So set it equal to 0. Okay, and I'm going to do this a little bit differently because of that value in front of x squared not being a 1. I'm going to use something called slide, divide, bottoms up. All right, it's just a fun thing to say. So I'm going to first slide this 2 to the back to multiply by that number at the end, my constant. So 2 times 2 is 4. All right, so then I'm going to factor as if I had this as my problem. I know this is not my problem, guys, but I want to factor as if it was. All right, so just like we did on the first example, are there factors of 4 that add to negative 5? And there are, negative 1 and negative 4. Now, again, I know this is not my problem, so I don't just say the answers are 1 and 4. So essentially what I'm trying to tell you is that was the slide, and now here's the divide part. So remember that 2, right, this 2 right here, that we slid to the back at the beginning. Go ahead and put that 2 underneath those two numbers that you chose as your factors of this kind of manipulated one. All right, if it reduces, go ahead and reduce it, right? X minus 4/2 is really x minus 2. 1 over 2 is not going to simplify anymore. So this is the bottoms up part. You take this 2 that's in the denominator, and it's going to go in front of that x to be 2x minus 1 as my other factor. Again, we make sure it's equal to 0. Set each of these equal to 0. All right, this one's probably more straightforward to see. 2 minus 2 is 0. This one might be a little tougher, so if you move the minus 1 to the other side, you get a positive 1. And if you divide both sides by 2, you get x equals 1/2. What a lot of students will start to see is that we actually already knew that before we did the bottoms up part, right? That was right here of x minus 1/2, telling us that one of our solutions would be positive 1/2. So these are the two solutions using a different way to factor when the number in front of x squared is not 1. All right, so that's it for factoring. You'll get a chance to practice both of these ways a ton. There's some right here if you'd like to do it. I'll show you right there. You can pause it and do as many as you want. All right, so let's do completing the square. This is the second way that we're going to solve a quadratic trinomial. I always try to factor first. Any teacher will tell you they will always try to factor if possible. It's the fastest way. But if not, then what I tell students is if this number in front of x squared is 1, then I'm going to use completing the square. I've been doing this a long time, guys. Most students will kind of just write off completing the square. Fair enough. If you can't factor it, most students will just use the quadratic formula, which you can. I just think it gets a little clunky, that's not a word, clunky, and using the quadratic formula usually results in a higher chance of student messing up. So I'm going to try completing the square. The first thing you want to do with completing the square is actually move that constant. So this constant is minus 15. Move it to the other side so it's over there to be a positive 15. Now, you might be wondering why I did that. Well, the whole point of this is if you tried to factor, so factors of negative 15 that add to 6, I've got negative 5 and 3, negative 3 and 5, negative 15 and 1, -1 to 15. Those are all my factors, but none of those are going to add to +6. So there's not a way to factor this. So we use completing the square as kind of like we create the number we want and then use that in this process. So the number we want is b over 2 squared. Okay, and that is going to be my b value, which is in front of the x, is 6 over 2 squared, which is 3 squared, which is 9. So by adding 9 to both sides, right, I haven't changed the problem, but by doing that, you'll notice on the left side now, x squared plus 6x plus 9 can be factored, and this is always how it will be. It will always be x plus this b value here divided by 2, which was 3, all that squared. If you're having trouble with that, you should hopefully remember that 3 times 3 is 9, and 3 plus 3 is 6. So you could write it as x plus 3 times x plus 3, but you know that two things that are the same multiplied together is really that thing squared. All right, so let's combine those. All right, so now I'm going to copy it again. When I'm doing this work for real, I don't do this, but I want to show you kind of what I'm going to do. We don't want it to be x squared, right? Do you see that squared there? So I'm going to take the square root of both sides. All right, so then I'm going to write x plus 3, because the square root of a square, those are inverse operations, they're going to cross out, equals plus or minus, because we took the square root of that 24. So the answer is going to be, when I move that 3 over, is going to be x equals -3 plus or minus the square root of 24. This is the answer. You can actually simplify the square root of 24 if you wanted to. Right, there's a perfect square in 24. The perfect square is 4, right? I'll do it over here. So I can rewrite this as the square root of 4 times the square root of 6. And we know the square root of 4 is 2. So this could be written as 2 times the square root of 6. So this is the solution. You can get decimals if you'd like, but you don't need to get any decimals for this class. All right, so that is the process of completing the square. It's kind of a way to manipulate the problem. All right, so we added b over 2 squared to make it so that we could factor, and then use this idea of the square root to figure out the answer. So that's completing the square. If you'd like to practice some completing the square, you'll notice that all of my values in front of x squared are 1. If it weren't, and it had most of the time, if it wasn't, you need it to be 1 so you can factor out, hopefully, there's a greatest common factor you can take out. Otherwise, that leaves us with our last one, the quadratic formula, right? If you don't know the quadratic formula, it's x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So the first thing I'll do is I'll write down my a equals 2, b equals -16, and c equals 27. All right, you'll notice that if I try to factor it, let's see, 54 when I do 2 times 27. So factors of 54, 9 times 6 is 54. That's close to 16, but not going to give me, that's going to be 15. So I'm guessing I won't be able to factor it. And I try completing the square, but if I try to factor out the 2 that's in front of x squared, I have 27 halves, which is not a problem, right? No problem with fractions. But most students won't do it when they see those fractions. So let's go ahead and plug in to the quadratic formula. The opposite of a -16 is actually 16. Plus or minus -16 squared. So that's b squared minus 4 times a, which is 2, times c, which is 27. Let's do some math here. Over 2 times 2, so 2a. So let's clean up the inside. So -16 squared is 256. And then this is going to be 4 times 2, which is 8. Let's see if we can do 27 times 8. Let's do 30 times 8 is 240. And then take away 24. So I'm going to go with 216. I think that's right. Let me do a quick little math over here. If you got your calculator, go for it. 56, 8 times 2, 16. I was right, 216. Look at that. All over 4. Subtract inside, and you get the square root of 40 over 4. This is the answer, but I can keep going. I can simplify the inside the radical, right? Again, like I did before, if I have the square root of 40, that's the square root of 4 times the square root of 10. And the square root of 4 is 2. I know that. So that comes out. Again, that's still the answer, but you can keep going. And you can divide this number, and the denominator all by a 2. So let's do that. 16 divided by 2 is 8. 2 divided by 2 is 1, so I don't have anything in front of that square root. 4 divided by 2 is 2. So this, again, if you want decimals, feel free to type it into a calculator, but that is going to be my simplified solution for that example. All right, if you want to practice, there's 2 right here you can practice. All right, and make sure you're doing your best to know how to use all 3 of these methods. Good luck.